Great. I was on mute. Hi, Enrique.
Yeah, I was going to tell you.
Yeah, and hello everyone, and welcome back to yet another session. We've got Enrique with us today. Enrique, why not just give people about a minute? And if you all can hear us and see us, just comment and just tell us where you're joining us from. Just say hi, where you're joining us from. We'll wait for a minute. If we hear from people, great. If not, we'll get started with the session, Enrique. Just in a bit.
Okay.
There, people can hear us. So there's someone on YouTube who's commented, "Hey there." Hi, Mohammed. There's someone who's already commented hashtag app. Perfect. So, there's a ticker going on at the bottom which says that if you want to enter the giveaway, we are giving away two MEEPs, early access books of Enrique's latest. So, comment hashtag app. Right. So, Mohammed is joining us from Iran. Hi, Mohammed. Welcome. Just have a look at the ticker and comment hashtag app. Yeah. Thanks for being the first one to comment and hashtag app, Jeffrey. All the best, everyone. And well, since we can see comments and people can see us and hear us, why not start the session? Enrique, do you want to start by introducing yourself, who you are?
Sure. So my name is Enrique Medina Montenegro. You can maybe guess from that I come from some Latin country, in this case, Spain. So I've been working for the last 25 plus years in developing applications. So I started as a normal junior developer and then moved up into being a solution architect. These days, I'm focusing mostly on developing web applications that are ready for the cloud. And as we are going to discuss here, lately I wrote this book with all the experiences, with all the lessons learned that I've had throughout my whole professional career, in order to share what I think is a very nice approach and a very solid and robust architecture that you can use when developing your applications.
Thanks, Enrique. I can see that there are quite a few comments that have started coming in. Leon says hi to you and nice to see you
Hi,
again.
Leon. How you doing?
And then we've got greetings from Armenia. Perfect. If you all have any queries and if you want Enrique to answer them for you, please feel free to add them in the chat. In the meantime, I've got quite a lot of questions, so I'll get them answered. So I'll pop them up on the screen. So if anyone joins in late, they know what we're talking about. So the first question that I have is, why isn't traditional CI/CD enough for modern software delivery?
Well, in this case, let me think about this, because this
Mhm.
is sort of away from the main content of the book, from the architecture. So it it is because I mean the CI/CD,
Ah,
or maybe you're
I,
asking
I
me questions.
yeah,
I
I can
think
see.
yeah,
Yeah,
I,
I
I
can see
got
why.
like a shock moment.
Yeah, sorry, my bad. I've got 4 sessions scheduled. I've picked up a question for someone
Okay,
else.
no
Sorry,
worries, no worries.
my bad.
Yeah, I was trying to come up with a
Sorry.
an answer that could just
Uh,
fit into the book.
thanks,
Okay.
thanks, thanks for being patient. So, why do so many applications become hard to change over time?
Yeah. So the main reason here, just to be very short, is accidental complexity. So accidental complexity is this complexity that grows when teams take shortcuts, or they
Hmm.
make design choices under pressure because they have some deliverable, they have some deadlines, these kind of things. So when you make these decisions under this pressure, then if you don't have the proper guardrails and the proper guidelines in your architecture, these choices will make your code brittle and difficult to modify. And most of the time, one of the reasons about this is hardwiring, when you uh, basically couple your code between the different layers. Like for instance, business layers depending on specific technologies like the database they are using, these kind of things. So this creates a ripple effect where a single small change in any of your layers, in any part of your system, then causes a lot of problems in many other files. So with the architecture that I present in this book, I try to overcome and provide a very disciplined and robust approach to trying to avoid these problems.
Thanks for that. Mohammed found it funny, but yeah, it was it was a bit silly. Sorry for that, and I'm glad that people have a sense of humor about it. We've
Indeed,
got
indeed.
people joining in. We've got Jose Lewis on LinkedIn saying hi guys. We've got Kaushik Mehta on YouTube saying hello from London, not too far from me. Uh, so my next question to you is, what problem does hexagonal architecture solve that layered architecture often doesn't?
So, as I already mentioned, the main problem is trying to avoid or try to minimize as much as possible, or at least keep under control, because architecture is not an exact science. I
Mm,
always like to say that the architecture is just a balance of trade offs.
yeah.
And therefore, besides the accidental complexity, it tries to solve the cascading change, this ripple effect that I commented before, which often occurs in a very unintentional way, but it still occurs because of many different reasons in all the layered systems. So, in a traditional three-layered system, for instance, there's always this idea that the dependencies flow downwards. So we typically have a controller layer or a presentation layer, then we have the service layer and the database layer. So typically, a change in one of the layers, the lower it is, the more impact it has on the upper layers. There
Mm,
are, of course, mechanisms, patterns, principles that you can follow if you are very disciplined in order to avoid these issues and mistakes. But if they are in a way provided with guardrails, with certain patterns, with certain solutions in the architecture itself, and not only that, we can also validate later that everything is being fulfilled with a tool that I describe and explain in my book, which is ArcUnit, then
mm,
we have at least much more warranties that everything will be done without getting and ending up in these rippling effects with cascading changes. And in order to achieve this as a teaser, mostly is by leveraging the principle of the audience probably knows there is these solid principles which are key in developing any software. So single responsibility principle, open close principle, leaf scope substitution principle, interface segregation, and dependency inversion. So the D in solid is a key actor in my architecture.
thanks for that, Enrique. Mohammed has asked a question on YouTube. He's saying that I've been actually using clean architecture in production for years. My question is that clean architecture usually used with CQRS and DDD, domain driven development, is it? Does the book contain
Design,
these
domain
subjects?
driven design.
Okay. Domain driven design. So does the book contain these subjects?
Yes, exactly those subjects. So for the audience not familiar with the CQRS, that's the Common Query Responsibility Segregation Principle, which basically tells you that in very big systems where performance is very key for reads compared to the writes, you can separate both models. So you can have sort of your logic for dealing with the write models, which are typically the databases, the transactional models, and then you can most of the time generate a read model, which is a flat multidimensional model from those write models. And then a typical example is when you have lots of different sources. I'm thinking, for instance, about the task manager, where you
Mm,
may have lots of different mini applications that deals with different type of tasks, but you want to have an aggregated view of the list of all your pending tasks. That can be a read model that is generated from all the different write models using many techniques that we cannot discuss in this session, like, for instance, events. And then your read model can be, for instance, a search engine like Elasticsearch these days, which can give you a much better performance when it comes to querying and sorting and ordering all the information all together. So in a nutshell, the answer is yes.
thanks, Enrique. And thanks for that question, Mohammed. And if anyone else has any queries, feel free to pop them up in the chat. This is the right time to get them answered by Enrique. So my next question to you, Enrique, is how can teams keep business logic from getting tangled with frameworks and databases?
Yeah. See, This is one of the key discussion points that I've always held throughout my professional career, because we have always had this promise that using certain technologies. So I remember when I first entered the world of Hibernate. For the audience that knows about this technology, this is the object relational mapper that we use in the Java world in order to abstract and provide this indirection and try to, let's say, decouple the details of the repository, the database, whatever it is, from the application. And I remember getting this promise in the documentation that, oh no, you use Hibernate, and then if you're using MySQL back then you can
Mhm.
change it for Postgres, and then you can use this, you can swap it for MongoDB or whatever. And while technically that was possible, it was not definitely the way, because the way that you structure and you model your physical models cannot even if you can swap them, cannot leak into your domain models, for instance. So
Mhm.
not only you need that abstraction in the example of Hibernate as the ORM, but also you need to have some clear boundaries, some guardrails that prevent those technical details from leaking into the core of your application. Because in the hexagonal architecture, the key takeaway is that you are developing an enterprise application that has business logic. And this business logic is what makes you different from any other application in the world that is also using MongoDB or the Spring Framework or whatever library, whatever language you may imagine. So what makes you different and what adds the unique value to your application is the business logic, is what in the hexagonal architecture is the application core. And that is what goes in the center. And with this application of the dependency inversion and the different, the concept of the ports, input ports to get input and trigger the logic in the application, and then output ports, both of them interfaces, to request data or services from outside of the application, the core of the application can stay pure, can stay clean, and can literally just focus on orchestrating all the steps that you need to do for a specific use case, for a specific use flow. And then all the dependencies in terms of information, services that it needs from outside, it just puts them in this abstraction of an output port. And then later we will implement it with whatever technology. But the center of the hexagon, which is the application core, remains clean, and therefore will not be impacted by any change in the surrounding boundaries, which are more technical concern, like REST APIs, like calling, publishing a message in Kafka,
Mhm.
storing data in some relational NoSQL database, and the rest of it. And also provides not the, let's say, original or the initial concept of the hexagonal architecture, because the book is not about describing or explaining to you what the hexagonal architecture is taking the hexagonal architecture, mixing it with DDD concept, and then providing you sort of a higher level architecture that provides several other mechanisms for very well known and well battle tested patterns that you can apply in the different layers to have a discipline that if you follow it, then you will be able to avoid all this coupling and all the accidental complexity that I have mentioned at in the beginning of the session.
Perfect. Right. So the DDD in this case would again be domain-driven design.
Domain driven design, yes.
Yeah. Mohammed has another question, and he inquires that my biggest problem with clean architecture is having multiple interfaces between layers and mapping objects. Does this book offer any solution for this?
Um, yeah, let's be fair here. Unfortunately, not. But this is not, let's say, how would I say that, a choice. So, as I mentioned before, architecture is a balance of trade offs. There
Mm,
is no perfect architecture. If someone comes here and tells you, I have the architecture that saves you from having to map between objects, to define interfaces, and everything will work and you will be able to literally plug whatever you want anytime you want, that person is lying to you for sure. So every architecture comes with advantages and disadvantages. What you need to evaluate is whether obviously the good things weight much more than, I would not call the bad things, because they are not bad in essence. It's just that they are maybe a little bit more burden. Some people call it over engineering, but
mm,
as I explain in the book, let me tell you that they pay off in the long term. So uh, in the book, I also developed this, and I have a very nice table where I literally tell you, if you're going to do a prototype or some, make and throw away application, these kind of things, do not use this architecture because it's going to be too much. In this case, you can tell me that it's over engineering. But if you're planning to develop a big enterprise application that is going to survive for years, that needs to be constantly updated to the new versions of the frameworks, the technologies, these kind of things, then the extra burden of defining these interfaces and the different models pays off. And eventually, even if you see it an extra work, you will see that with tools, as I explain also in the book, like map extract in Java, they make the mapping between objects almost declarative in a single line of code. And you don't need to be always working with these methods that are always doing or fetching all the getters of a class and then putting it in the setters of the other class. So while there are techniques to make this much more, let's say, user-friendly, much more fun, still it's unavoidable if you want to really achieve the pure decoupling in your application.
thanks for that. And Mohammed has even replied. He's thanking you for your response. Okay, I'll
Okay.
move on to my next question. Thanks again for that question, Mohammed. And my next question is, why is separating the core domain from infrastructure so important?
Yeah, because of all that we have been commenting so far. Because, for instance, the typical mistake I've seen because I've been working before this, I was working mostly with 3 layers architectures, developing web applications, mostly in the Java ecosystem, but this applies to any kind of language and any kind of other ecosystem. So the problem is that you have this fake feeling that because you know that there are 3 layers and the communication between layers is done through an interface. So in a way, you are leveraging this principle, this D in solid, which is the dependency inversion. Then you have this fake feeling that you have everything decoupled. But then you create an object model which represents, let's pick up the example I used at the beginning, a task. And then at the beginning, it's just a plain old Java object. It's just a pointer with getters and setters. That's it. Then, because you start to use it in the REST layer, which is your presentation layer, your controllers, then obviously you need to serialize and deserialize this to JSON. So, okay, let's use some Jackson annotations to annotate it. Then you move it to the service, and in the service, you may need maybe some other, mostly in the service because it's more the business logic. You typically do not pollute it too much, but then it comes to the data layer. And then because you're using, for instance, Java Persistence API or one of these object relational mappers, then you start annotating it with entity annotations because you already have the model there. Your Another mistake that typically the people make is starting to implement the application by defining the physical model in the database and
Mm,
then doing this bottom-up approach when it should be the other way around. But
right.
that's another discussion. But because they do it sometimes that way, then they say, okay, because I started with the physical model and then everything is just coded around that structure, why not also annotate with these entity annotations, these JPA annotations, whatever framework I'm using? And at the end of the day, you end up with a big object model that literally gives support to all the mutations that you need through the different layers, together with all the possible annotations and technical concerns around. And then your code must always be checking and having these ugly if or switch statements. If you are maybe smart enough, you may use strategy patterns and these kind of things, but eventually your code is mostly trying to reason about the mutability of an object that should not have been shared between all the three layers in the first place. And this is a very common mistake that I've seen almost everywhere I've worked. And in this case, again, this is the accidental complexity. And this is something that the architecture forbids by definition. So if, as I explain in the book, in the chapter dedicated to the testing of the architecture with ArcUnit, if in an object that is defined in the domain model,
Mm,
so in the core of the application, it finds any import from something that is not the plain Java SDK or certain allowed libraries that you agree with your team. In my case, I'm a fan of Lombok, some Apache Commons libraries in the Java world, and of course, um, the book explains that the architecture suggests and strongly recommends to take a functional approach to the implementation. And for this, I use a library which is called
mm,
vavar.io. And of course, the map extract that I mentioned before, in order to be able to translate between the different models in the different layers. So in this case, the the check that you do of the architecture with ArcUnit will prevent you from leaking anything that is not part of those agreed and allowed libraries into the application core. And therefore, you will immediately stop one of the main core mistakes that people make when developing in other layered architectures.
perfect. There is a long question coming up. Before I pick that
Okay,
up,
let's get
yeah,
ready.
yeah, brace yourselves and again have a sip of water if you want to. But before I pick that up, I just want to remind people that we are almost at the halfway mark. So possibly on the other side of this question, and after Enrique's answered it, we'll do our first giveaway. Have a read through at the ticker at the bottom. It says if you comment hashtag app, yeah, you will stand a chance. Like just do this. A lot of people have already commented. So if you can see this, just comment hashtag app and then you stand a chance to win one of the books in Meep. Okay. So the first question is from Leon on LinkedIn. Leon says for smaller projects, the full approach, that is, separate models per layer, DTOs, and mappers at every boundary, can feel like more ceremony than the project deserves. I've been slimming it down to just the dependency rule. The domain stays free of infrastructure, but ports are just interfaces, and I skip the rest. Where would you draw the line for a small project?
Yeah, I believe it's in chapter 2 or chapter 1. Yeah, there are so many chapters that I have in my head at the moment that I cannot be precise on that. But I explained that I do it briefly because that's not the core content of the book for obvious reasons. But I explain, and I think I already mentioned that when you developing a prototype, proof of concept, this minimum viable product, where you are uncertain of whether that development will continue or not. So there are sort of reasonable chances that you may throw away that code. Then if you are not, let's say, familiar or very experienced, or if you have not even ever worked with the hexagonal architecture, then I strongly recommend you not to use it. So I'm not here to sell you that my architecture is the architecture whatsoever. I'm just trying here to give you, convey you the message that if you have a long-term application where, and this is very important, it's not only about the complexity of the application, it's about also there are many non-functional details that you need to take into account. In my case, I came up with this solution because I lead most of the time technically very big development projects where tens or even sometimes, well, few times, but sometimes I've had to lead hundreds of developers. These days they are located everywhere in the world in different time zones. So you cannot be, let's say, always available to them to answer the questions, to solve their hesitation, their doubts. So you need sort of a way, a discipline that can be executed in code,
Mm,
not just on paper, because if you just give a 100 pages document to anyone, they will not read it and they will just do whatever they feel they have
mm,
to do. So in this case, all these tools, all these guardrails I've been talking, this arc unit, the way that you can unit test everything, because everything is so simple, so let's say pure. You don't have to spend a lot of time in creating very complex test cases that which end up being very complex integration tests. There is a whole chapter in the book just dedicated to unit testing with what I call mechanical ways of testing each layer. So once you do a test for a command or a query or a handler, then all the ones that come after that will have exactly the same pattern. So if you provide these solutions, these heuristics in a way, this discipline, and you can enforce it mechanically in the code itself without literally having a person reviewing absolutely every change you make, then you have the tool and you have the warranty to delegate and, let's say, sleep better, because you know that at a certain level everything will be under control and there is no place for derailing in a way to speak. Obviously, again, this is software, everyone can do everything. I always tell the people that you could literally take the architecture and make the handler, which is the application server that sits in the center to orchestrate the different steps in the use cases, define an output port, and then put all the business logic, all the decisions, everything that is really unique for you in the implementation of the output port. And there's no way to, let's say, spot that or detect that with software. These days, probably with the AI, you can do it. But let's say with just something like a static analysis, like a Sonar Cube or Arc Unit, there's no way because your architecture, you're fulfilling the architecture. It's just that you put in things where they do not belong. So while the architecture and all the implementation that I do throughout the book tries to give you as many guardrails, as many patterns, as many automatic discipline to, let's say, release the team from having to make decisions all the time about how do I do this, where do I put this, how do I deal with this new requirement. Even with all of that, still, obviously, there's always some discipline, some, let's say, authoritative uh, person in the project that needs to be supervising everything. So uh, the response to the question, besides all that, is that I would only think about it for long-term enterprise applications that heavily rely on business logic, together with let's say, those applications where they may not be so complex or they may not be so big, but because you've been working with the architecture for years and you are experienced, then you can just afford starting everything as well, using this architecture, because for you it's very easy. And also these days with the AI, because everything is mechanical in the architecture, you can literally define skills that generate all the artifacts for you. But that's another discussion that we can have in another session. And literally have very clever coding agents that know your architecture and know exactly what they need to do.
perfect. Thanks a
Just
lot.
as a teaser.
Yeah. I can see quite a lot of people have quickly just commented hashtag app. Jose, I can see that you've got another question, Jose, lined up. I'll do it after the raffle, and Leon has quickly entered in as well. So I'll just share my screen. Let me know when you can see it. There. And I can see 8 people have entered the raffle. All I have to do is just click draw, and now it will randomly pick up the first winner. For others who still haven't commented now. There's still chance. So our first winner is from YouTube learner ED1PO. Congratulations! If you're seeing us live, please add me on LinkedIn, as my name is over here. Just type Tushar plus Manning, and then I'll coordinate and I'll get you your MEEP access. In the meantime, I'll take up questions. Congratulations again, and just add me up on LinkedIn, and I'll get you your book. Uh, so the next question is from Jose on LinkedIn. Jose inquires that in model, is it better using rich model entities where entities manage the logic inside themselves, or is it better to have domain services managing entities?
Okay, this is a question that enters into the DDD, the domain-driven design world, which is one of the key pieces of the architecture, because the architecture fits it very well. Okay, so I mentioned previously that the domain model in the architecture in your application that stays in the center of the hexagon should be a rich model. I didn't mention the word rich, but I said that it shouldn't be a plain old Java object, and therefore you need to avoid this anemic domain model mistake, which is just creating an object that has getters and setters, and is just literally a bag of data. That is the role reserved for the DTOs in my architecture. But the domain model must be, as Jose Luis is saying, a rich model that not only has a state, so attributes, but also behavior. What that means is that, for instance, getting back to the task example that I've been using throughout the session, imagine that you have this use case where you have a task manager and then you want to assign an assignee, a person, a user to the task. But in order to do that, you have some logic, because depending on the role that person has in the application, different permissions, these kind of things, you need to either assign one or other user. In this case, that logic belongs to the rich model. So you would have a task class in Java, and then you would have a method, for instance, assign, okay, that will take the current context, the current state of that task instance object, and figure out what it needs to be done. The problem, and just to follow on the question, is that sometimes to make that decision, the context that you have in the object instance, which, by the way, in the DDD world, most commonly will be an entity that is an aggregate, the context that you have in that moment is not enough to make the decision. You need extra information. So DDD is very clear in telling you that a domain model should not call output ports. That is done through the handler, through the application service. DDD is also very clear to tell you that you should not modify or work with aggregates from another aggregate. And this is where I reply this question. If you feel that in order to uh, provide the logic to assign a task, the context of the object, the aggregate that you have at that moment at runtime is not enough, then this is where the application service, who, remember, is the orchestrator of the user flow, kicks in and says, okay, because I know my domain, I know that my domain, for instance, needs to have, I don't know, let's make it simple, a list of privileged users. Okay, but obviously not every task in my model needs to store the privileged users in order to make that decision. What the application service, as a handler, as I explain in my book, is, okay, I fetch for you those privileged users, in this case, either user a repository or an output port. And once I have those privileged users, then I send them to you as an argument, in this case, to the method assign. So the domain can make a decision, and all we need to do is use the application service orchestration to provide all the information that is required. But this could get even more complicated, which is what happens when that decision also depends on the state of another aggregate. So DDD is very clear here. It tells you if you find in a situation where completing a certain use case requires managing different aggregates or combining them or somehow dealing with them, then this is when, as Jose Luis is posting in his question, you need a domain service. So the quick answer would be avoid domain service unless you find in a situation where everything that I have explained to sort of support your decision logic fails.
Thank you. Yeah, Leon is happy with the response that you gave him for the long question earlier. Thanks, Leon.
Thanks, Leon.
Yeah. And people just keep commenting hashtag app if you want to be one of the raffle winners. We've got one left, which I will do towards the end. But in the meantime, I'll just get my questions answered as well. So, my next question to you, Enrique, is how does hexagonal architecture make testing easier and faster?
Yeah, there is a whole chapter dedicated just to this, to the unit testing of your application. Why? So there are mostly three to five reasons. So I'll try to make it short. So the first one is, as I already commented, because everything is pure, everything is driven or defined in terms of external dependencies by interfaces, then we can use in the Java world a tool like Mockito, which is just a tool, a library for mocking dependencies. And because this is a very lightweight tool, it just mocks whatever the output port you have defined, for instance, in an application service. You can just set these expectations that given that someone calls to my output port, I provide this static response. Because if you think about it, you don't need to, let's say, take into account how that dependency works in order to test, in this case, for instance, your application service. You just need to make sure that if that dependency provides an expected result or an unexpected result or an error, then you are able to react properly and you can provide the logic that the application requires. So in that regard, that's very easy. So we can talk about literally millisecond execution speed. The other one that I also already mentioned is mechanical testing recipes. So you will see that commands and queries are always tested the same way. Handlers, application services are always tested the same way, but just mocking the ports. And then, for instance, controllers also are testing by mocking the bus, because this has not been yet commented, but also throughout the book, as part of the solution, I use this command and query bus pattern. And
Mhm.
therefore, in the controller, you just need to mock that bus, and that's it. So you don't need to start up the full, if you're working with Java and Spring, all the full Spring Boot application and these kind of things. And that's very important, mostly these days when we are literally committing and deploying into production every hour, or the sooner that we can. So the more time we can save in making the warranties that everything is properly tested, but not spending too much in the CI/CD on the testing phase, that's really nice. And then another very important key piece of the architecture is that, as I mentioned, I'm using a functional approach with a monad, which is just let's say, construction that is provided in the functional world by this vavar.io library, which is called either. So everything throughout the application is driven by either structures. So either is just this structure that allows you to always reply, therefore return to a certain method by either providing an left side or a right side. And because right side has the word right, and right in English is correct, the right side is always the valid value and the left side is always an error. you can use either with exceptions or, as I explain in my book, I don't like exceptions because they eventually, let's say, you lose the control. But in this case, with either, you can combine it with an approach that I describe in the book, which is using error values. So every time that you execute a piece of code where an exception could be leaked, then you wrap it in another monad that is part of this library called the try monad. And then any exception that occurs within that piece, that block of code, is automatically converted into an either, in this case, a left either, because it's an error. So with this, what we achieve is that the testing failure paths and in general, the failure paths of the applications of your code are much easier because you only need to assert on a return value rather than trying to catch, all the possible exceptions, be them checked or unchecked, or deal with most of the time the most problematic part, which is a hidden call stack. And of course, on top of this, there is the arc unit with, once you have unit tested everything, then you proceed with the architectural tests that basically try to catch whether you're leaking technical details in the different layers where you shouldn't.
We've got a question on YouTube. Let me try and get this name right. I think it's Zimitri Harnau. Uh, and they inquire that do such architectures designed to help human understand an app and support technical agility still make sense in the era of AI?
Indeed. And as I was sort of teasing before,
Hmm.
I think they are the perfect couple because for those who have already worked with AI, with the ChatGPTs, with the Cloud Codes and all this, if you don't give precise instructions, they will end up generating different code for the same prompt every time. And this undeterministic approach of LLMs is something that some people may want or may love because they just want to create quick applications and just prototypes or whatever. That's fine. Remember that before I said don't use hexagonal architecture for a simple prototype. But if you think about it, if you have a mechanical way of implementing your application with these guardrails, tools, heuristics, etc., that are provided and explained throughout the book, then this is the perfect couple for an LLM because
Hmm.
you can put them in Markdown, for instance, as an agents.md. And then, for instance, I've been experiencing later with adding one skill per each of the different artifacts that go in each of the different layers of the architecture. So if you can manage to make the LLM understand what your architecture is, what the things can be done and cannot be done, and then you provide the skills, for instance, to generate automatically these artifacts, then it's the perfect couple because you have sort of a controlled by coding, so to speak, which allows you to do anything you want, but make sure that whatever is generated by the AI is done within the boundaries of an architecture that you know, that you understand, and that you can at any time step in to manually modify something without just being, like most of the time these days, a black box that only the AI understands.
Hmm. Perfect. So my next question would be like, how can teams introduce hexagonal architecture without rewriting everything?
Well, this is tricky. Again, I wish I had sort of the magical answer to this one, but in the book, I develop throughout the book, I develop an application which is not an enterprise big application. It's just to fit for the purpose of you having some code to experience and to play with. Uh, Let me also mention now that together with the book, you will find in my GitHub lots of supporting libraries that allow you to, let's say, start working right away without having to define certain core, let's say, code or scaffolding, as I like to call it, in your application. And of course, with regard, for instance, to the ARC unit, I already provide you with many rules, or at least the ones that in 95% of the cases have been useful in the projects I typically work with. So getting back to the question, I develop together with this application in the book, which is called Write Flow, uh, um, let's say a process or a workflow or a migration map in a way that is composed of 5 steps. So in a nutshell, not to get into the details because this would be um, yeah, endless. So phase one would be around extracting the domain. So you have an existing application. So you go to your application and try to get only the object models that are part of your domain, not the request response models, not the, I don't know, entity models that you are using for your ORM, sorry, just the domain and the
Mm.
business rules that you identify throughout your application. And then you isolate them, then you define the ports uh, as interfaces. So any dependency that your application currently have, in plain words, whenever you call an external API, you talk to a database, you publish a message in Kafka, all this, you can also identify it in your code and also sort of stock it and then translate it into the different ports. Then the specific code that you have that now implements that dependency of, for instance, calling an external API, then you put it in an adapter that implements the output port that you have just created. So you wrap the existing code, most of the existing code, into these facade adapters that implement the output ports that you came up with when you evaluated all your different external dependencies. And then most of the time, you will have this concept of service classes. At least in a 3-layer architecture, you always have the service class. And those who have been working with the Spring framework, you will be very familiar with the add service annotation. So you take those classes, and then once you have extracted the domain model, the business logic, and the code that is about dependencies, you will most of the time see that all the code that remains is precisely the orchestration code. So the steps that you do: first go to the database, fetch this, then send it here. With the response, go here. So that code is what is left in your services. Then that goes into the handler, into the application service, and that's basically it. And then the phase five would be once you're while you do the replace and verify, depending on the confidence you have about it, you always try to work with vertical slices. This is very important. Uh, Approaches I've seen to the layered architectures is about completing one layer and then going to the other one. The hexagonal architecture is perfect for working with vertical slices. So what I call the complete user flow of a use case, from the request that you get in your input adapter as a REST layer, to translating it into a command or a query, to putting it in the bus, to getting into the application service that orchestrates your use case and then calls all the different dependencies through output ports, repositories, and then back, in the case of a query, to the controller layer. Once you complete one complete vertical slice like this one, then you can automatically use ArcUnit. So first unit test it, then ArcUnit it, and once that says okay, then you can continue with the other one. So just slicing it in that way, it's very, let's say, convenient, and would help you into refactoring your application and moving it to the hexagonal architecture in a nutshell.
Perfect. I came prepared with a follow up question to this one because I think this has to be spoken little bit at length, and rightly so. So, the approach that you just shared about unit and then moving it to the different unit and then checking it, how does this approach help applications survive changing tools, APIs, and frameworks?
Yeah. So because everything is isolated through the concept of the ports,
Hmm.
uh, let's say that, for instance, as part of the refactor, you want to move from one repository technology to another one. So when you take your legacy code, where that code around the specific repository technology. Let's assume, or let's pretend it's a relational database, is leaking throughout all your different layers through the data models, or even worse, through direct calls from layers that they shouldn't. Then once you, let's say, identify it and remove it in a way and document it as part of these phases, then because you will abstract that behind an interface, a port, then you can either reuse that code or literally throw it away and implement it in the new changing API tool, whatever you need. Of
Mm.
course, when it comes to external dependencies, so external systems, database technologies, these kind of things, this is pretty straightforward. But again, I want to be fair and transparent all the time here. Uh, if you're talking a much more serious refactor, like for instance, uh, you are developing with Java and Spring, okay? And then you want to move to another framework like Quarkus or Micronaut, then it can also be done, but then you need to, let's say, be more experienced, because in this case, whenever you read the book or you go to my GitHub account and you find this right flow hexagonal reference application,
Mhm.
you will see that eventually Spring is only present in very specific modules, which are, of course, not part of the hexagonal core. So directly out of my head, I can think of the REST input adapter. So I'm
Mm.
using Spring MVC in this case, but I could literally switch that layer without touching any of the rest of my application by just implementing it in Micronaut or Quarkus, or even in plain Java with Jax RS specification, for instance. Then the other place where I have a Spring is in the module, because we have no time to talk about this, but in the book, I also not only explain you the architecture, but also provide you with a guided structure of multi-modules, in my case with Maven, but you can use Gradle or you can use any other build tool in any other ecosystem that creates one independent module for each of the layers in the architecture. So we have a module for the application core, another one for the input ports, command queries, and output ports, another one for the input adapters, another one for the output adapters, etc. And there is a one, let's say, module that governs them all, like the Lord of the Rings. So a ring to govern them all, which is called, in my case, because I use a Spring Boot, it's the
Mm.
Spring Boot assembly that uses the dependency injection, in this case, which is the mechanism to enforce the dependency inversion in order to assemble everything together. And again, if I wanted to change it to Quarkus or Micronaut, then I would just have to replace that Spring Boot assembly module for a Micronaut assembly module or whatever. So obviously there will be impact to my application. I'm not saying it's a zero effort
Mhm.
approach, but you know exactly what you need to touch, and you have everything completely as isolated in their own modules. So it's just a matter of re-implementing them with the new technology. That's all.
Perfect. I'm mindful of the time that we've just got about 5 minutes left, and there are three quick questions that I need to pick up. So before I pick up those questions, uh, yeah, there's a ticker going on at the bottom. We're going to do another raffle at the last minute. So please comment hashtag app as you see down here. Yeah.
Yeah.
I'll quickly ask you these questions, Enrique. We'll try to be as quick as possible. And so, Itakir on LinkedIn inquires: Is distributed world a choreography world, or how to do saga hexagonally?
Okay. Let me be a bit devil here. This is exactly part two of my book.
Right. Perfect. Uh, Check the book out.
So
Uh,
so hexagonal architecture
yeah.
definitely indeed helps with this.
Perfect. Check the book out. Comment hashtag app. Comment that, and you could probably just win it for free. If not, check the book out. Another quick question before I pop up the final one. Alvaro on LinkedIn inquires: do you think that this architecture is only suitable for enterprise applications, or it makes sense also in other types of applications like standalone or desktop apps?
Yeah, Alvaro, you were probably not at the very beginning of the session because yeah, this has been commented before that. So as a quick answer, uh, let's say the short answer is use it only when you have sort of, the thing is, I don't like to use the word big because what is big? Big for me could be millions of lines of code, and big for you could be some tens of thousands of lines of code. But when you have an application that you know it's gonna have to survive long term, where you know that during that process you will have to probably switch technologies, where you know that during that process of development updates to the frameworks, to the technical concerns around the application will be required. Uh, these days, for instance, for the Java audience out there that use the Spring Boot framework, uh, they released last year Spring, sorry, they sort of recently, if we think about the whole, let's say, lifetime of the project, the Spring Boot 4, and people are struggling to see how they migrate from Spring Boot 3 to Spring Boot 4. With this architecture, I can tell you, you only have to change two modules, the REST adapter and the Spring Boot assembly. That's it. And of course, if in the implementation of your adapters you are using a specific Spring Boot 3, then you will have to migrate them. But you don't have to touch your application core, your business logic, and all the, let's say, translations between the different layers. All this is warranted because using the architecture. So just to complement on this, for prototypes, for minimum viable products, for things that you know you are uncertain of whether they will end up being a real application and these kind of things, unless you are very experienced and you almost do it mechanically, or you have your AI agents generating everything for you, don't use it.
Perfect. Last call for comments. Hashtag app. Itasir, sorry, I'm butchering your name. Was yeah, he's commented right on time. So yeah, please comment this, and I'll take my final question. And I'm sorry, Enrique, to keep you this long, but the final question is quite relevant, and it's about the book. Who should read your book, Clean Applications with Hexagonal Architecture, and what will they build better after reading your book?
Yeah, so because we're talking here about this concept of big enterprise applications, I'm pretty sure that not everyone, and these days with the vibe coding and all that, are facing this challenge. So in this case, I'm thinking more about these experienced or at least junior to senior developers with at least 3 to 5 or even more years of experience that have been working in projects, having this feeling that the project starts fine. They start using very cutting edge technologies. Everyone is very happy. But then after 6 months of development, everything goes out of control. Every small change that they make feels like a risk. They don't want to touch here, or whenever they get a bug, they say, "Oh, I don't want to touch that part because every time we touch that, everything breaks." So there is this constant tension in the development team. So if you have ever felt or worked in that kind of environment in terms of development, you are familiar. You don't have to be an expert, but you are familiar with concepts like the ones provided by DDD, the ones provided by patents like Command Bus, Command Query Bus, the Command Query itself, these kind of things, and also with the solid principles, which you should be because they are core principles in any kind of development. And you also want not to spend too much time because no one likes to do unit testing, then this is your architecture.
Perfect. Yeah. If you're scared of your legacy code crumbling, check the book out. We'll do the final raffle now. So our first winner was Learner ED1PO. please get in touch with me, and yeah, I'll arrange for your book. And here's the final draw. Let's see who wins. We've got one winner from YouTube. Let's see if we get one from LinkedIn. It would be a nice balance if we get that. Hey, Alvaro. Congratulations,
Alvaro.
Alvaro. Uh, yeah. Oh, and he commented at the very last second. There you go. Look at this. Very cheeky of you, Alvaro, to get in at the last second. And congratulations. Yeah, I'll get in touch with you, or you contact me on LinkedIn. Either way, I'll arrange for your meet. And congratulations. And thanks, Enrique, for your time. Thanks everyone for joining. I've got another session next week on agent design patterns. Join me for that. And there is another one the week after. And well, basically, there's one every week. Join me for more sessions to meet experts like Enrique. Enrique, do you want to share any closing thoughts before we wrap up?
Well, first of all, join the agent design session to create your agents to generate code for the hexagonal architecture. That's one thing you can find the
Same.
the connection, the synergy
Yeah.
there. Okay,
Yeah.
because everything is related these days. And no, just as I was saying, this is just literally my experience of more than 25, close to 30 these days. I'm getting old. Of participating in so many projects, having this feeling about that things derail after typically 6 months for some
Mhm.
reason, and then having to find a solution for leading very big projects where I don't have full control over all the developers, where I had to provide a discipline in the team so that they did not have to make decisions other than thinking about the business logic itself,
Mm.
to facilitate how to integrate with other technologies without having to reinvent the wheel every time. And the result and the final, let's say, tool that tries to solve all those problems with real code. So this is not a theoretical book that talks about things on paper, because paper can eat everything. This is real. This is libraries that you have that you can start using right now. This is code that you can start literally coding just before this session, and using nothing but well-known techniques, principles, patterns, and in this case, as the foundation, I'm using the hexagonal architecture. There are other similar architectures are there. So the sort of the father of all of them is the clean architecture, and then we have the hexagonal architecture, onion architecture, and there are many flavors of them. I just chose this because when I evaluated everything, that was the one that really felt that it could fit better to the way I develop applications. And I strongly encourage to play around with it and buy the book, participate in the forums in Manning, and yeah, contact me if you want to follow up and keep discussing about this. I'm very happy, and people who know me know that I love to debate and discuss and get challenges about everything every day.
Perfect. Thanks a lot, Enrique, and thanks everyone for joining. I'll
Thanks
see
to
you
you, and
all.
thanks to the audience.
Yeah, perfect. Thanks to everyone. I'll see you all next week with another session. Ciao.